Welcome, ladies and gentlemen, to Chemical Compositions and Reactions. We are talking about oxidation numbers, part 4. Today's topic is going to be determining the chemical formula for polyatomic ions by using their oxidation numbers. We're going to start with the two elements of sodium and the polyatomic ion bromate. Now, sodium you should already know because it is an alkali metal in the first column, group 1. So you should also know its oxidation number is a positive one. However, you probably don't have bromate memorized. So what you do is you go and you look at your chart. And you can see that bromate is BrO3 -1. So you go and you write that down. Now, this isn't going to be much different than it was for single ions. You simply have the ions written, and then you bring down the crisscross, and you see you have the ones. Now, if you remember the rule, if there are ones, you simply eliminate them. You don't bother to write them down. So this first example of sodium and bromate is actually pretty simple. All you do is put the different ions together, and you have NaBrO3. Okay, the next example is sodium and peroxide. And again, you probably don't have peroxide memorized. So go to the chart. Okay, peroxide you can see is O2 -2. It is similar to oxygen gas, except that it has had 2 electrons added to it. Okay, so O2 -2. So you go back and you write down your ions. Okay, same process. O2 -2, you bring down the criss and the cross. And it should be pretty simple. Remember, you eliminate the ones and you just leave the 2 where it is. And sorry about having this be up instead of down. That should be an O with a subscript of a 2. Okay, our next example. What do you do if you have magnesium and bromate? Bromate, remember, is BrO3. You did that in the first example. Okay, so no problem for the bromate. You bring down the 1. However, when you bring down the 2 from magnesium, it'll look a little strange because you already have a 3 there with the bromate, the BrO3. So the question is, what do you do so that it doesn't look like, BrO32? Okay, well, first you get rid of the one with the magnesium. You know you don't need that. And then all you need to do is take some parentheses and put them around the bromate. And that separates out the polyatomic ion. And that means you have 2 bromates. Okay, so that is the finished answer, Mg parentheses BrO3, close the parentheses, and the 2 on the outside. Okay, the next example is ammonium andborate. Okay, you might not know either of these. In fact, you probably don't. So, you go to your chart and look up ammonium. This is NH4 + 1, and by the way, this is the only positive polyatomic ion, so it'll always come first, just like the metals. Okay, then you have to go and look up your borate, and you can see it is BO3 -3. So then you go to your problem and write them both down. Now for the process overall is the same. You bring the 3 down from the borate, you bring the 1 down from the ammonium. You get rid of the 1, and you have this 3 in the middle that seems kind of lost, because you don't want NH43, you want 3 NH4s. So just like before, even though it's at the front, all you do is add the brackets, and your correct answer is parentheses, NH4, parentheses closed, with a 3, BO3. So that actually means you have 3 ammonium ions in this, just like you have 3 oxygens. So you would have 3 nitrogens, 12 hydrogens, 1 boron, and 3 oxygens. Okay, you have a worksheet to do where you're going to be using the crisscross method for polyatomic ions. Realize if there is only 1 polyatomic ion, you don't need the parentheses. The only time you need it is if the subscript is more than 1. Okay? If you have questions, let me know, and I will talk to you tomorrow.